So roughly 50 tons of space material hits the Earth every day. So that's about 15 to 20,000 tons every year. And about another 5,000 tons of dust crashes into our planet as well. So this is stuff that's falling from space, so bits of asteroids, bits of comets, bits of other planets that have been knocked off by collisions, and all that material is floating around the solar system, and every now and then some of it bumps into the Earth. So like I say, 50 tons a day roughly, so a rain of space material coming out of the sky. So I've said that the sort of stuff that hits us is bits of asteroids and comets. So the question really is, what are asteroids and comets? Well, asteroids are basically rocky and metallic objects, and comets are icy objects, but they do still have bits of rock and metal mixed into them. And they're useful and interesting for us because they are the leftovers of the formation of the solar system. So this is stuff that's been around for 4.6 billion years since the sun and the planets formed. And the asteroids and comets are useful for us to study because they're material that was around in the nebula, the cloud that was there when the solar system was created, and they're still out there floating around now. So if we can study them, we're studying primordial material from the very, very beginning of the solar system 4.6 billion years ago. So you may have heard of terms like meteor and meteorite and be wondering what these actually mean. What's the difference between them? Well, a meteor is basically a sand grain sized particle. It's a very, very small piece of metal or rock, often associated with comets. So meteor streams and storms are sort of material that's fallen off a comet, and the Earth passes through the path of a comet in the solar system. But those are very, very small particles. A meteorite is a bigger lump of rock that actually hits the ground. Meteors burn up in the atmosphere. Meteorites actually land on the surface. Now, very, very bright meteors we call fireballs, and those are very noticeable because they're brighter than Venus. So if they're really, really bright, so even brighter than a fireball, and they explode in the sky, so something like the Chelyabinsk event from 2013, then we call those a bolide. So we see examples of impact craters on the Earth, but they're very heavily eroded and buried under the sea and under forests and things, so it's quite hard to see them. But if we look around the rest of the solar system, we see lots and lots of clear evidence for impacts having occurred over the last billions of years. So the closest example obviously is the moon. So if we look at the moon, and you can do this just with a naked eye, the moon is absolutely covered in craters. And if you get to the surface of the moon, like the Apollo astronauts did, then you'll find craters down to the size of dust grains. Okay, so everything hits the surface of the moon. There's no atmosphere there to protect the surface. So the moon's surface is absolutely battered. And even the large darker areas, the mare that we see on the moon now, those are impact craters as well. They're just huge impact craters where something has hit the surface of the moon so hard, it's drilled a hole right the way down to the sort of liquid rocks, the magma underneath the surface, which has then come up and basically flooded the impact crater. So lots and lots of small craters all the way down to microscopic scales, but some really, really gigantic craters on the moon as well. Now, elsewhere in the solar system, wherever we see a solid surface, we see evidence of impact craters. So the surface of Mercury is absolutely battered, Mars is battered. Venus, well, it's a bit of a strange case in the case of Venus because it has a very, very thick atmosphere that kind of protects it. It rotates really, really slowly, so a day on Venus is actually longer than a year. It takes longer to spin once than it does to go all the way around the sun, but it's upside down, and we think that was because once upon a time in the very early solar system it was hit by something very, very big, so effectively a planet colliding with a planet and rolling it upside down. Uranus is orbiting the sun on its side, so that was probably again hit by something, or something came very close to it and gravitationally rolled that planet over because it's a much bigger planet than Venus, so it was harder to move. The fact that the Earth has a moon is probably down to a giant impact as well once upon a time. So a body about the size of Mars, maybe half the size of the Earth, collided with us. The metal from the core of that planet was absorbed into the Earth and gave us a bigger, more powerful magnetic field, which is useful for life. But the rocky rubble from that explosion, that collision, went into orbit around the Earth and eventually coalesced to form the moon that we see today. Mars is missing a few kilometers of its northern hemisphere crust, and we think that was probably due to the fact that a giant impact blew the surface off Mars. And even Mercury. Mercury seems to be a giant core with very little in the way of mantle or crust, so probably an impact created that situation as well. So impacts have had a massive role in changing not just the small scale features of the solar system, but the way planets move and orbit as well.